Hi everyone! Welcome to our iStopShaking project. Now that you've learned a little bit about neuroscience from our previous video, we're going to jump right into a project idea that our team is currently working on. And for introductions, hello, I am Tiffany.
I'm Nitin.
I'm Shripad.
I'm Jane.
All right, let's get started. Who are we? Our team is High Tech and Neurological Disorders, or HAND, at UCLA, and we are a student organization aiming to increase awareness and education of neurological diseases such as movement disorders, such as Parkinson's and essential tremors. And an innovation aspect includes our undergraduate prototype team, which is currently aiding in the prototyping of iStopShaking models. And our hand innovation team is composed of our medical advisors and 25 undergraduates, which include majors ranging from engineering to even design and business. What was our purpose going into this project? We had three main points. First, to increase the overall quality of living for patients with essential tremors and or Parkinson's disease. Second, to grant patients freedom of everyday tasks through the use of patient and AI-controlled gyroscopes and accelerometers. And third, to track patient lifestyle data along with tremor activity in order for physicians to develop specific treatment plans.
As Tiffany mentioned, one of the main reasons why we kind of chose to start this project was because there is a big population of people living throughout the world that have essential tremors and Parkinson's disease. And these two conditions can really affect their function in their daily life. And so we wanted to be able to create a device that would help alleviate some of the burden that these conditions kind of pose upon them. So essential tremor is the most common movement disorder that's seen in expert clinics. And so around 7 million people in the US have essential tremor. And so that means this is affecting about more than 2.2% of the US population and about 4.6% in the global population. So with essential tremor, hand tremor is usually the most common, but you can see tremors in the head, arms, voice, tongue, legs, and trunk. And these tremors are most noticeable when you're holding the hands outstretched or making fine hand movements, such as holding a cup, using a spoon, or writing. So if these tremors are affecting the patients when they're doing fine motor movements, this will severely affect their ability to perform certain tasks or activities of daily living. Parkinson's disease, on the other hand, is a neurodegenerative disorder that's characterized primarily by loss of dopamine neurons in a brain region called the substantia nigra. And so symptoms generally start on one side of the body slowly over the years, and then will progress in different ways depending on the person, because this is due to the diversity of the disease. And so people with PD usually experience tremor, mainly at rest, bradykinesia, which is slowness of movement, limb rigidity, and gait and balance problems. So nearly 1 million people will be living with PD in the US in 2020, and more than 10 million people worldwide are currently living with PD.
So what has been the timeline for iStopShaking? As I previously mentioned, the project idea and research started back in 2016. And so between 2016 and 2017, I worked on filing the patent proposal, and we sent it to the USPTO, so US Patent and Trademark Office. And after some back and forth between our lawyers and advisors, the patent was finally granted in June of 2020. And from there, we launched High Tech and Neurological Disorders at UCLA, which is our organization currently, and prototype development has thus begun here on campus.
So what is the iStopShaking device? And let's look at some of the patent components. Well, the three IoT or iStopShaking wearable devices are designed to minimize and reduce the shaking of the hand, head, or foot caused by neurological disorders such as essential tremors and Parkinson's disease. So on the right here, you can see our design for the glove, something that could be a neck bracelet, something that could be a leg bracelet. These are just some of the ideas that are covered under this patent.
So the design for the iStopShaking device is based on three foundational principles. The first is calibrated gyroscopes and accelerometers, which we use to sense and then counteract the tremors. The second part is the interface and dial, and the user will have direct access through this through a mobile app, and they can manually adjust any change in the gyroscope. And the third is built-in sensors, and we use this to monitor the patient's activity and vital signs, and this data is also sent wirelessly through Bluetooth to the connected device.
So how exactly is the iStopShaking device going to work? Well, the first component talks about gyroscopes and accelerometers. Gyroscopes use the Earth's gravity to help determine orientation. Its design consists of a freely rotating disc called a rotor, mounted on a spinning axis in the center of a larger, more stable wheel. So we can see a GIF representing this in the bottom left corner. Next, we use accelerometers that measure acceleration, how fast the gyroscopes are moving. Accelerometers are used to sense both static, like gravity, and dynamic, like sudden starts and stops in acceleration. Each iStopShaking device contains between 24 to 30 mini gyroscopes and accelerometers, as we can see as little black beads in this design, connected to multiple tracks seen by little tubes running towards each of the fingers. 5 hollow tubes with up to 30 gyroscopes are connected to a brushless controller and brushless, slotless DC compact motors, which have high acceleration, low noise, and are connected to a rechargeable battery power source. Each of these components is important in order to maintain the easeability of use in this design.
So like we mentioned previously, the system also includes a dial controller for the user to control the angular momentum and the spin axis of the mini gyroscopes. And we do this in order to ablate the shaking movements relative to the purposeful movements of the user. And the user also has access to a digital interface of the device to control other things in terms of the settings like the pairing, calibration, and tracking.
So the third part of the patent is the vitals and lifestyle tracking. So we're going to create an app that connects to the device, whether it's the glove, the neck bracelet, or the ankle bracelet. And so this app will basically sync up all the data that the accelerometers in the glove or neck bracelet or ankle bracelet itself is tracking and show it on this digital interface so that the patients who are using this device will be able to access data for their tremor activity, exercise, heart rate, skin temperature, and exposure to radiation. And so users will also be able to manually input their sleep, diet, and mood. And so this digital interface will be connected to wireless CPU with Bluetooth. So this will allow the data to be shared with caregivers and physicians. So ideally, we would hope that this tracking of data will allow physicians and patients to work together to identify trends in their tremor activity and hopefully modify their personalized treatment plans based on this activity. And also, we're going to be looking at how to make this app accessible for individuals in rural areas who may not have access to internet.
So what is the competitive advantage of the iStopShaking device in comparison to other treatments on the market? Well, current ET or essential tremor treatments include medication like beta blockers, tranquilizers, and anti-seizure medication. And the surgery options include deep brain stimulation or DBS, ultrasound, and thalamotomy. The current PD or Parkinson's disease treatments include medication like carbidopa, levodopa, dopamine agonists, and more. And the current surgery options include deep brain stimulation. Now, something like medication is something that people need to take over a long period of time, and they need to continually take in order to maintain. And something like surgery has its own innate risks when having to do the procedures.
So adding on to Sripad's comments on our competitive advantage, iStopShaking allows for a non-invasive approach. The wearable devices allow for flexibility and customization, while also allowing patients to better perform everyday tasks. Additionally, iStopShaking is planned to be sustainable and accessible. So each device will be made to be rechargeable and made of recyclable materials, which reduces medical waste and requires only a one-time purchase for immediate use. And thus, these 2 points contrast with current solutions available on the market, which includes medications and surgery approaches. So now that we've reached the end, we have some closing thoughts we would like to present to everyone.
So we hope you guys had fun learning today about neuroscience in general and our iStopShaking project. And so we can understand that especially during this time when most of your learning and schooling is virtual, it can feel really hard to kind of conceptualize like, why am I learning what I'm learning? Is there any purpose to this? What can I actually do online if I'm interested in finding out more about these certain diseases or conditions and seeing like what I can do to maybe make a change or get involved in these types of projects. We just want you to know that a lot of us do feel the same way, and there are many resources out there for you to kind of get on your computer, find out more about these diseases, and you can connect with different organizations that are working with addressing these conditions. And even though you're in an online setting, the world is your oyster, and we hope that whatever year you're in, you find joy in what you're learning at school, and then hopefully outside, possibly through organizations like this.